Okay, so on the handout there, we're just looking at a couple of formulas for summations that will pop up here in just a moment. First one is, if I have, here I is my index, so if I'm just summing 1 to n of just I, it turns out there's a formula, and it's you just take the n, which the n I'm referring to is this, times n plus 1 divided by 2. Well, here's example number 1, go 1 to 10. What this says, this means 1 plus 2 plus 3 plus 4 plus 5 all the way out to 10. Right? What this formula says is you can shortcut that instead of having to add them all up. Just take the n, which is 10, times the n plus 1, which is 10 plus 1, which is 11, divide that by 2, and that gives you 55. So if I add all these numbers up, I get 55. And that wouldn't be too hard to check. Somebody might check it just to make sure, but if you add those up by hand, you're going to get 55. So what would it be for 1,000? I equals 1 to 1,000. Well, it would be 1,000 times 1,001, right? Add 1 to it, and then divide by 2. And so that gives you, well, it would be 500 times that, so it would be 500,500? Okay. So that's a quick way to add up 1,000 numbers in order. Anyway, okay. But we'll see this more in just a second, but it's n times n plus 1 over 2. We actually won't have a number here to evaluate. We're just going to use I equals 1 to n. We're going to use that formula. Well, it turns out if you do the squared numbers, 1 squared, 2 squared, 3 squared, those numbers turns into this formula. It's n times n plus 1 times 2n plus 1 divided by 6. Now, if you want to know why that is, that one's a little easier to explain. This one's not too bad, but it just turns into that formula. And then if we do the I cubes, well, it's n times n plus 1 over 2, but you square it. So if I did I cubed here, I would just take this and cube it. So I would take 55 and cube it if I was doing the I cubes, or square, I'm sorry. 55 and square it if I did the I cubes. So it would be 55 cubed. That would be the answer there. But anyway, just some interesting formulas. I don't think actually I'm going to use that one. I just threw it in there. All right, now, Glenn, would you mind scrolling me up, bring 4 up here to where I can see the rest of them? Yeah, that'd be good. Thank you. Now, there are a couple other notes on the sums. If I'm doing I equals 1 to n of just c, where c is a what? C is a constant. It's just c times n. Why is that? Well, if you write it out, you've got c, 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 right? Because nothing's changing. The index is not affecting that, is it? Because every time you're just adding up c. So you've got c plus c plus c. You got c n times. C plus, that's n times c, or c times n is the way I write it there. That's why, when you do a constant here, it's just c times n is the result. Because when you add n c's together, you get c times n. Okay. Number 5 there, well, I use f of I here because I could be I squared, it could be I cubed, it could just be I. But if you have a times something to do with I, essentially what this is saying is you can bring the a out. Why is that? Well, the first one, you'd have a times f of 1. Then the second would be a times f of 2. The third one would be a times f of 3. These are just going to have a factor of a in it. So this a is just a factor, if you will, that you can factor out front. As we factor that off, you just say f of 1, which is the sum of the f's of i's right here. That'd be the sum of the f's of i's. Okay. Okay. Number 6 we actually just talked about, because here we're just talking about the sum of two things added together. And certainly you can just do the sum of this plus the sum of that. You could throw in the minus there. If it's f of I minus g of I can say f of I, the sum minus the sum of the g of I. So anyway, so if it's a sum, yeah, you can split those sums up, one sum into two sums. Okay. So all that being said, here's something we might encounter in just a moment. Let's simplify this sum right here. Well, by property 6, can I, since I've got two things added together, I can separate those into separate sums. See what I did there? Yeah, if two things are added together, you can separate them into two sums. Now what can I do on the first sum here? Well, isn't this, I mean, it's pretty complicated, but isn't this essentially just a constant? Because really we're saying n is just some number, a and b are just some numbers. This is a constant. So what can I do with that? By property 5? It can bring right outside, yeah. So this is a minus b over n times the sum I equals 1 to n of i's. Now, do you notice what I can do on that? No? Yeah. This is c squared. If it was I squared, I'd use property number 2. This is just c squared. Isn't that just a constant squared? I mean, don't let the squared fool you. Yeah, this one's just like number 4. Now it's c squared instead of c, but I mean, c squared is just as constant as c is, right? Yeah, so this is just a constant summed out. So what is it? Constant times n. C squared times n. Last but not least, what is this one? Now that one is back on property 1, right? The sum of the i's, what is it? N times n plus 1 over 2. That's property number 1 that we talked about. So a minus b over n times, then that would be that formula we had, n times n plus 1 over 2 plus c squared n. One other thing, do you see something else we can do? Because we're not going to be able to simplify just a whole lot here. I can cancel the n's here, can't I? So I wind up with a minus b times n plus 1 over 2. And let's just do it this way. A minus b times n plus 1 over 2 plus c squared n. Okay. It's not really, but it's all constants there. I mean, plug in a's and b's and n's and c's. You got it. But all right. So we don't get to do a whole lot of that, and I wanted to show you that because what I want to do next is another handout, because like I said, I want to show you here a neat little deal.